Now, let's look at hypothesis 3. So hypothesis 3 is about the intervention group and the intervention group only. So it tells us, it hypothesizes that BDI levels have decreased in the intervention group between the baseline and 1 week. So here we only want to study the intervention group, which is coded 2. So first thing we're going to do here is we're actually going to filter our data set so as to only filter in the intervention group. So we're going to click on data, select cases. So the intervention group is group 2. So we're going to change this to not group equal 1 or group equal 2, but only group equal 2. So I'm going to click on continue. So this will filter in only group 2 so that we can study it and only study this group. Let's click on OK. Now you see I only have, so we can check that again. We can do something like this, descriptive statistic, and check that I only have the intervention group. Everything is as intended. So now we are in the intervention group, so that is already taken care of here. The question is, BDI levels have decreased between the baseline and 1 week. So here we want to compare these two, baseline and 1 week, in this group. But again, we're already filtering in this group only. So what we have here is a case in which we will really compare these two repeated measures. So this could be addressed notably with a paired samples t-test, or an equivalent would be a repeated measures Anova. So we're going to do both here. So I'm going to click on Analyze, and no need to select them first, right? So I'm going to click on Compare Means and the paired samples t-test. Next, I'm going to compare here. So I need to compare the baseline and 1 week. First one is baseline here. The second one is 1 week. And yeah, that's it. Click on OK. Let's look at the result. So I have a paired samples t-test here. So I see that it's computed as baseline minus 1 week. In other words, here, baseline, we can check that as well here. So baseline is higher than 1 week, which is why this difference is here positive. And we see that it is, we look at the two-sided p-value, it is significant here with p is equal to 0.002. However, if we do that, there are other things that are missing, especially means plot. So an alternative here would be to use a repeated measures Anova framework, which we can get from using Analyze, general linear model, and repeated measures. We're going to define our repeated measures factor. Let's call it just time. And here we are only comparing 2 levels. We're going to write 2 in the number of levels and click Add. Define. And then I'm going to select my 2 repeated measures. So that's the baseline and 1 week. And what I'm going to do is I'm going to make additional selections here. Notably, I'm going to click on the plots here. And I want time. I won't want the BDI levels as a function of time. So I'm going to select time here as the horizontal axis. Click Add, a line chart, and include error bars, which will be here confidence intervals. I can also get my estimated marginal means at the different time points, 2 time points here. Click on continue. And I'm going to also select an estimate of effect size. That's it. Okay. The test of sphericity has really no relevance when we only have two repeated measures. So we can skip it and go directly here. So here we have the effect of time, which we're studying. So we're going to assume sphericity, but again, there's no question about assuming sphericity or not if we only have two measures, two repeated measures. So here I see the F over here with 11.43 degrees of freedom 1 over 39, and the p-value is 0.002. In fact, it should be the same p-value as the one we had previously, and we can check that with more digits. 16,001,653 should be the same as this one over here, right here. Okay, perfect. And what's nice about using, however, the repeated measures menu is we can get other things, especially we have estimated marginal means with the means and their confidence intervals. And we also have them in a plot over here, which is nice for publications or posters or presentations. Okay, so the answer here is that BDIs have significantly decreased in the intervention group between the baseline and 1 week, and we can cite F test over here, and the p-value is 0.002. And the analysis here would be called paired samples t-test, or here repeated measures Anova. Hypothesis 4. So BDI levels have decreased over time in the intervention group. So now it's a more general question. Why is it a more general question? Because here we're only questioning potential decrease between baseline and 1 week, versus here we're studying over time in general. In other words, we want all 4 repeated measures. Now, when we are considering all 4 repetitions, we cannot use the paired sample t-test anymore. So here we only have one option, which would be to use the repeated measures Anova framework. Lucky for us, it's exactly the same menu as the one we've used, except we're going to have to add these two additional repeated measures, these two additional repetitions. So we're going to click on Analyze, General Linear Model, Repeated Measures. And this time I'm going to remove, actually probably change it. Change it, instead of having 2 levels, going to have 4 levels. I'm going to click on Change. Then now I have time with 4 levels. And if you're starting from scratch on this question, you can actually start from scratch this way, add it over here. As long as you have time, 4 levels, that's essentially all you need. Or you can call it something else in time. You can call it repetition, for example. I'm then going to click on Define. And so now I have my 4 levels, 1, 2, 3, 4. The first two, let me set this. So first one is the baseline. The second one is 1 week. Third one, 2 weeks. Fourth one is 3 weeks. So that's it for specifying the model. Now we're going to add new things that we might want in the output. Notably, we're going to want plots with time as the horizontal axis and the DV BDI levels as the y-axis, which is anyway the default. And click on Add Line Chart, keep that, and I'm going to include error bars with confidence intervals. I'm then going to click on EM means to get the estimated marginal means as a function of time. If I want pairwise comparisons between the different repetitions, I can click on Compare Main Effects. And finally, I'm going to click on Options. I'm going to click on Estimates of effect size. I'm going to click on OK and see what I get as an output. So lots of things. Let's start with the beginning. So typically here, we would start by looking at the test of sphericity, which is an important assumption for repeated measures. Here we have a significant test of sphericity, which means that we have a significant non-sphericity, which indicates that we should prefer one of the corrections. So ideally here, if you were to report this test, you would probably use one of the corrections instead of assuming sphericity. But in the present situation, actually, it doesn't change the conclusion. So I'm not going to spend really much time on this. What we see here is we have a significant effect of time. It doesn't really say whether it's a decrease or increase. However, if we look at the estimated marginal means, we see that overall there is a decrease, 36.5, 31.0, 27.7, 23.7. So there's overall a decrease between each between the time points. And we actually see, so we have here pairwise comparisons. We see that 1 is significantly different from 2. 2 is significantly different from, no, 2 is not significantly different from 3, actually. 3 is, however, significantly different from 4. So we have here also a plot of the decrease. So what we can say here to address this is we can say that BDI levels have significantly decreased over time in the intervention group, and the F test we would report for that would be one of these. So depending on the one we are using, we would use the corresponding F value and the corresponding degrees of freedom and the corresponding p-value. And if we want a measure of effect size, the partial eta squared. And as a representation of the effect, we could produce a plot with the estimated marginal means. Let's look at question 5, hypothesis 5. I should say, so BDI levels decrease over time in the intervention group, controlling for openness. So now we cannot only use a repeated measures ANOVA because now we need to control for openness. So in other words, now we need to use a repeated measures ANCOVA. So the way we can do that is really very simple, especially now that we have specified this this analysis overall without controlling for openness, I should say. So I'm going to click on Analyze, General Linear Model, Repeated Measures. I'm just going to recall the same dialog boxes. This has already been defined, so I don't need to do anything. Actually, you can just click Define. And the new thing here is that I'm going to select Openness. Now, again, we are still only talking about the intervention group. So it's already been filtered and everything. So keep that in mind. That's important here. Even though we've done it before, but that's important. We are addressing an hypothesis that is still about the intervention group only. So we are still working on the filtered data with only the intervention group. So we keep these 4 levels, but now we're going to control for openness right here. I'm going to click this. I'm going to keep the same outputs. So notably in the plots, I'm going to keep a plot where I see time as the horizontal axis in a line chart with confidence intervals. The estimated marginal means also as a function of time, keep with the comparisons between time points. And also I'm going to keep estimates of effect size. So this is going to be really very similar, this repeated measures ANCOVA, very similar to the repeated measures ANOVA, which we've previously talked about, except that now we have a model that actually controls for openness levels. So we're going to look at the, first we're going to look at the Moschli's test of sphericity, which is significant here in the present case. suggests that we should probably use a corrected test, which doesn't really impact the result here. What we see here, so we have here the overall effect of time, and here we have an interaction between time and openness. And so what it tells us here, first off, is that the effect of time, so in other words, the evolution over time, actually depends on the openness levels. So we have because we have a significant interaction between time and openness. In other words, depending on your degree of openness, your evolution over time of depression varies. And the main effect actually in present cases is not significant. So really the answer to this question is a bit tricky. The answer to this question is it depends. So overall, it's hard to say because it actually depends on the degree of openness. So let's look now at the estimated marginal means, which we have over here. So we tend to see a decrease, very similar to the one we've seen before. We have differences between the time points individually. And so here we have seems also a decrease. So this represents estimated marginal means, and here openness is actually fixed to its mean, which is 64.7.